How long does it take to get to the center? How much does it take to break this? What is this? And what is this? Stick around, we're going to find out. Hey everyone, welcome back. I'm Scott, Edge of 3D. It's been a little while. Been out of the country. Went to Southeast Asia for a couple of weeks, Philippines to be exact, and if you haven't been there, give it a try. It's a wonderful country, beautiful people, and I'll throw a picture of a jeepney up here somewhere. I got sidetracked. I got hooked on these jeepney things there. I couldn't get enough of them. There's a whole story to the jeepneys. Maybe another video for another day. Anyway, picked up a channel sponsor again. Not a video sponsor. They're not sponsoring videos, but they are sponsoring channels, or the channel, my channel. It's Polymaker, of course. I've worked with them in the past. Wonderful company, and they have wonderful filament. But Polymaker has, really pushed me to do lots of material testing. The problem is, I can get all the Polymaker material from Polymaker that I want, but how many tests can I do on just Polymaker material? Want to do tests on all the other brands. Watch on Discord and Reddit and that and see what the latest trend is that people are using this material for this purpose, and pick some of that up and do some testing. So, you've seen in some shorts and that, I've been building a new testing rig. It uses a closed loop stepper, big heavy duty unit. I've loaded it to over 500 kilograms of force, which is quite violent when it finally breaks, and quite interesting. But I'll save those for shorts. But so the purpose of all this is going to be, it's not ISO standard. It's going to be TLAR standard, which is what I use. And for those of you that aren't familiar, it's called That Looks About Right. So it's not going to be testing done to a standard, but it's going to be testing done to the exact same standard each time on the same machine. So I'm starting back over from square one. I'm retesting everything I've tested, and you're familiar with the Izod machine that I built. I haven't changed anything on that. It just flat works. So that's where this piece goes into the vise, and the hammer comes down and breaks it. Measures how far past after it breaks that it goes, and this is PPS carbon fiber, so quite honestly, this doesn't even slow the hammer down. This is an amazing filament, but it doesn't take a shock load. So that testing will continue as is, both annealed and unannealed, and anything that benefits from annealing, I will be annealing here in the annealing oven. It's running right now. It's got, actually I think it's got some of these in it. And on that subject real quick, if you've watched my dryer videos recently, I was always curious, when you put a roll of filament in a dryer and it's, let's just use 20 degrees Celsius ambient temperature in the room. You put this in a dryer and it's set at 70 degrees. How long does it take for the 70 degrees to get to the core of a roll of material? And that's where I took this roll of ABS, drilled a hole in it, embedded a thermocoupler right into the center of the core and sealed it in there. And I've showed you on a couple of videos how long it takes for that temperature to get to the core of the material. So I started wondering, well, when I put something in the annealing oven, how long does it take for this 125 degrees to get to the core of this part? So I printed these 100 millimeter cubes, and they have thermocouplers embedded into the center of them. And there's one actually in there right now. And I'm thinking 100 millimeter cube, it's going to take quite a while, and I was a little shocked at the results. When I started this yesterday, Ambient temperature here in the room was just under 18 degrees. The first measurement I took inside of here was 18.3. 2 minutes later, when I actually started recording, so there's the temperature on the screen here, there's the temperature. I have one thermocoupler just in the middle of the box in here, and then I have one of these set up in there, and I was really surprised. I only took 3 samples from 9:06 to 9:35, so basically over a 30-minute period. We went from a 20-degree box to a 125-degree box. The core on this sample at the start was 18 degrees. At 30 minutes, it was 107.4 degrees. So the heat transfer, at least on PPS carbon fiber, got to the center a lot quicker than I thought it would. Now this is printed with just Voron Standard, and I'll post that in the video description down below, exactly what I use for Voron Standard as far as the number of the walls, top and bottom, and infill percentage, and what type of infill I use. But it was just something interesting I was curious about. Now I know. Because I was wondering, because they Polymaker says to anneal this for 16 hours at 125 degrees. And I'm like, does it take 16 hours for that heat to get to the center? Does it take 8 hours? Does it take 2 hours? You know, I don't really understand the methodology behind the length of time for annealing. I hope to educate myself and learn that. And I'm sure there's people going to be commenting on this that are way smarter than I am. Kind of like the lady, the engineer from that was at 3D Printopia that was talking to me about the testing machine, and she grabbed a notepad and she started writing out what I need and how I needed to do it and all that. Just phenomenal people out there, way smarter than I'll ever be. Anyway, she got me headed in the right direction on the testing machine, and that's why I built the new machine, and that's why I'm doing these new samples. So, you know, just the material strength sample itself is going to be these dog bones here, and they're 5 millimeters thick, 10 millimeters wide. They're printed solid, and I use so that it all prints. It's all layers are oriented the same direction, so everything is laid down longitudinally along the path there for the breakage testing on that. This is what I've come up with for a layer adhesion test. And this is a 10 millimeter cylinder in the center. And these are printed obviously standing straight up like this, so that when it breaks, it's going to give us a layer adhesion. And these are printed. I'm doing Voron Standard on these. I've actually done some testing, both printed solid and Voron Standard, and there's not much difference. So, but I am still going to do annealed and unannealed. And then something new that I'm going to work on is testing, that as far as the machine testing goes, testing the pull-out strength of heat set inserts. So I print these pieces here. They're laying down like that. And what I do is I set a heat set into them. You can see right there. Then I take and screw a 3 millimeter screw into it. And I have this other part, and these both lay down in that rig, and it pulls on this just exactly the same as it pulls on these. And finding out where and how and at what kilogram of load does the heat set fail. I've done a couple of test pulls so far, and surprisingly enough, the heat set didn't fail, the print itself failed, and basically the core broke out of the top and the bottom, and it just basically pulled it apart. So going to be playing around with that, and then I'm also printing a set of these where they're going to be direct thread. Now, PPS carbon fiber, probably not going to be just screwing a thread or screwing a screw down in there to it, because I don't know how well, the stuff is so brittle it'll probably shatter. So I might wind up using a tap and tapping it and then threading direct into it and pulling it, but time will tell on that. So that's where we're headed with the machine testing. I'm also designing some devices where I can do some creep testing, where I will take and print a part and load it with weight and just let it set over time and measure it over time, see if there's a measurable, if there's a measurable stretch. Same way with torquing one piece down to like a 2020 extrusion, torquing a 5 millimeter bolt into there, a 3 millimeter, and letting it set over time, and then coming back and seeing where it's at and how many turns it takes to get back to the torque that it started at. So those are types of tests that are going to take time. They're not. I'm not going to sit down today and say, all right, I'm going to do creep tests for next week and put something together like this and all of a sudden have creep tests. Which, if you've seen the video on this, this was a heat test, and this is PA6 carbon fiber, and this over here that turned into liquid was PA12. So there's a video out there about this, but this is one of the tests I came up with, and it's I print these parts out, I put them here in this oven, and I start 5 and 10 degree increments, just depending on how high a temperature we're going, and I let it soak for an hour, and then increase the temperature, let it soak for an hour, and I document each hour as to where these are sagging at, when they start sagging. And you can see this PA6 carbon fiber that was annealed, it's bent. It's obviously, the part is no good anymore, but it's not failed. The PA12s, both annealed and unannealed, failed a long time ago, and they didn't just fail, they just disappeared. They turned to liquid. There you go. That's liquid PA12 carbon fiber. So that's what I'm working on, and everything will be continually going into a database that is be up on Google Documents, and I'm sure Polymaker will wind up posting those same documents somewhere. And there is no preferential treatment to Polymaker. Polymaker will not see any of these videos before I publish the results. If I'm doing a comparative testing between Polymaker's ABS and Brand Z's ABS, and Brand Z's ABS outperforms Polymaker on every single test of mine using my standards, Polymaker will find out about it when they watch the video the same time as you find out about it. I do not share these videos with the channel sponsor ahead of time. They are simply sponsoring me for the content, and they're going to use it for their own purposes too. If they see something that's performing better, they're going to look into why, and we're going to dig down into it and get raw ABS, raw ASA, colored ABS, colored ASA, and test the differences between those. See, does the coloring really make a measurable difference? Stuff like that. And any material that you want to see, if you want to see a set of material run through these tests, drop it in the comments down below. Let me know what it is, where to get it. I'll get some ordered, I'll get it tested. So that's it. Just want to get everybody up to speed on where the channel's headed, what's the latest. Stick around. If you like these videos, hit the thumbs up. If you want to see when I drop the next one, hit that bell icon. The goal is to drop a video every single week, but I also have a full-time job that takes me away from home once in a while, so I might miss a week here and there. But the goal is get you guys a video once a week and start getting some material testing out there and get a comprehensive chart. And like I say, it's not an ISO standard. You can't take my results and go compare them to what somebody's publishing as their ISO results, because I don't have ISO standard machines. I don't have the budget to buy ISO standard machines. And why should I buy ISO standard machines and reproduce the exact same that somebody else is doing? I'm trying to do more real world type stuff. So what does a Voron spec printed part do as far as layer adhesion? What does a Voron spec heat insert hold? Those aren't ISO standards. those are my standards, which that looks about right. So I appreciate each and every one of you. Really appreciate ModBot for throwing my channel name out there. I was in the Philippines. It was the middle of the night. I was sound asleep. All of a sudden my phone started blowing up. People on Discord, hey man, ModBot just dropped your channel on his channel. And I go onto my channel and I look, and here's my views, and all of a sudden there's just this line that goes straight up out of space. So if you want to get a whole lot of views on your channel, slip Daniel a little cash and have him mention your name. Not that I did that, but it sounds good. Thanks everyone for sticking around. Hope to make this fun. Hope to make this enjoyable. Hope to get you guys some information that's actually relevant and usable. And if you have ideas for tests, you know, if you've got an idea for some kind of a test rig, and it's got to be something that I can build relatively at home. I mean, I do have a mill right here behind me, and I've got welding equipment, metalworking equipment at my office and stuff like that. So I can build some complex things, but I'm not going to build great big elaborate things. What I want to do testing with is stuff that I can also throw my design out there on the internet, and you can build it and do your testing with the same equipment, not $50,000 one-off lab machines and stuff like that. Homemade equipment for makers to use at home to do their testing if you so choose. So keep the comments coming. I appreciate each and every one of you once again, and as always, peace out.